Chapter 11, Section 6 is going to go over how we can add and subtract these rational expressions. So a couple of sections ago we went over how to multiply and divide them. And now we're going to take this a step further and we're going to talk about how to add and subtract. Now, adding and subtracting fractions, remember that you do have to have common denominators. So the numbers in the bottom of the fractions have to match before you can operate with them. That's a little bit different than what we were doing with multiplying and dividing because we didn't need to have common denominators. So I'm going to go over with you guys some examples of how to find the LCD, how to create that. So if you need to manipulate one or both of your fractions so that they match, we can do that and then be able to add and subtract our numerators. And then at the very end, go over if there's anything that we can simplify. So we're going to start with this first example, where we've got 3x squared over 4 plus 5x over 6. So right now you can see that 4 and 6 are in the denominator. They do not match right now. So we need to try to figure out what is the least common denominator, or LCD for short. And that would be what number can both 4 and 6 go into. Now there's lots of options here. 4 and 6 can go into a lot of the same numbers, but you want to maybe try to pick the smallest because it's going to help you out in the end so that you're not having to do a whole bunch of extra simplifying at the end of your problem. So I'm thinking about the number 12 because I know 4 can go into 12 and so can 6, and I think that's the smallest LCD that we're going to find. So now what you have to do is try to change both of your fractions so that you have a 12 in the denominators for both of them. So for that first one, you have that 3x squared over the 4 on top. You need to kind of ask yourself, 4 times what would get me to 12? Well, 4 times 3 would get me to 12. Now, if I multiply the bottom to change that, I also need to multiply the top. So you're going to take that 3x squared times 3 also. So you're going to do this, and then we also need to change that second fraction, which says 5x over 6. And again, we're trying to get that 6 to become a 12, and so we can do that by multiplying by 2 on the top and on the bottom. Because 6 times 2 is 12. And then again, same as that first one, whatever you do to the bottom, you have to do to the top. So then to simplify here, on the top we'd have 3x squared times 3, that would become 9x squared. All over 12, and then plus 5x times 2 would be 10x, all over 12. And then I'm going to add my numerators, because now that my denominators match, all I need to do is add these two things together. So it's going to say 9x squared plus 10x, all over 12. Remember, when you're adding and subtracting fractions, you only add the numerators. You don't change the denominator once you've got it to be common. Now, something to get in the habit of is when you get to this point, see if there's anything on the top or on the bottom that you could possibly factor out. So this one on the top, all we can really factor out is x. And I would be left with 9x plus 10. And I took an x out because I saw that they at least each had 1. I can't do anything to the bottom, so I'm going to leave that over 12. Now, the only reason why I would suggest that you guys get in the habit of doing that is because eventually there's going to be some problems where we see something that's the same as on the top as it is on the bottom, and you're going to be able to kind of cross those pieces off. This one doesn't have that happening, so we're going to go ahead and just leave our final answer there. So it would be wise to kind of get in that routine of factoring, if you can, taking out anything that you see they have in common, because like I said, some problems in the future, if we do that, we're actually going to be able to cross some things off. Let's take a look at another example together. So this one we have negative 2 over 3xy squared, and then minus 6 over x squared y to the third. We've got numbers and we've got letters involved here. So what we need to do is kind of look at the bottoms of those fractions and see what is maybe missing from one fraction that the other one has. And so we need to be able to kind of combine them, and we want to take like the most amount of factors that we see in the bottom of a fraction and make sure that the other one has the same amount. So in that first fraction, I see a 3. The second fraction does not have a 3, but because the first one does, I'm going to need that second one to have a 3. So I know I'm going to need a 3 in my LCD. Now I would look at your x's. This one is just x, but the second one is x squared. So we're going to want to make sure that we have two x's, or an x squared, x times x. And then you look at your y's. You've got y squared and y to the third. Again, you're going to want to make sure that you have y to the third, because that's going to be the most amount of y's that we need to have in our fractions so that it matches that second one. So when I look at my first fraction, 3xy squared, I have the 3. I don't have x squared, and I don't have y to the third. So you need to kind of, at this point, ask yourself, if I'm looking at this first fraction, what do I need to multiply to get that 3x squared y to the third? Like I said, we already have the 3, so you don't need to multiply by any numbers. But I need to get x to become x squared. So we should hopefully know by now that x times x is x squared. And I need a y squared to increase by 1 more. So I'm going to multiply this first fraction by xy. Then we have a minus sign. For our second fraction, we have 6 over x squared y to the third. Now my letters match my LCD. I have x squared and y to the third, but I don't have that 3. So I need to multiply the top and the bottom by 3. You're basically going to multiply your fractions by whatever is missing from the LCD. So sometimes it could be just a number, sometimes it could be just letters, sometimes it could be a combination of both. So now if I multiply across my tops here, I'm going to have this negative 2xy for the first fraction, all over that 3x squared y to the third, that LCD. Then we have minus, the second fraction says 18 on top, and we still have 3x squared y to the third. At this point, you know, your denominators should match, and if they don't, you probably did something wrong. You need to kind of go back and reevaluate that. So to simplify this, on the top it's going to be negative 2xy minus 18 all over 3x squared y to the third. And again, I would kind of look to see, you know, in the top, is there anything that you could take out? Well, you can maybe take out this negative 2. And so you'd be left with xy minus 9, or sorry, plus 9, because we took out a negative 2. And it'd be all over 3x squared y to the third. Again, it's just good to get in that habit of factoring, so that if I could cancel something out, I would at this point, but there's really nothing that I'm able to eliminate, so we're just going to leave our answer in that form. So what I want you guys to do now is pause the video, try to do this practice problem, and then come back and keep watching to see how it should have been worked out. So first thing you need to do is identify your least common denominator. So for this one, the LCD is going to be x squared y, which the first fraction already had that, so you really don't need to do anything to the first fraction. But we do need to change our second one just a little bit. We're missing the x squared, so we need to multiply by an x on the top and on the bottom to get that to show up. So we have 2 over x squared y minus, on the top you're going to have x over x squared y. And then the last thing I would do is just combine my numerator, so it's just going to say 2 minus x over x squared y. And this time there really isn't anything to factor out from the top, so we're just going to leave it right there. All right, let's take a look at this next example here. So for this next one, we have 1 over x minus 1 plus 1 over 1 minus x. If we look at our denominators right now, they are really similar to each other. And I'm wondering if there's a way that I can maybe switch this around, one of them, so that they match. It might be easier for us to switch the second one around and leave the first one alone. So I'm going to see if I can get the denominators to both say x minus 1. So I'm not going to do anything to my first fraction since it already has the denominator that I want. But if I switch the bottom of the second fraction around, I'm basically taking that 1 and that minus x, and I'm going to have them switch places. So it's going to say negative x plus 1 instead. Now what I'm going to do is see what can I maybe take out of that second fraction on the bottom to make it become a positive x plus 1. And again, this kind of goes back to when we were factoring in chapter 8, how we saw a lot of times with our factor by grouping problems that if you pulled in that negative to the second grouping, that you tended to take that out in order to get your signs to switch so that the quantities inside of your parentheses would match. So you're going to want to make sure that you can do that still here. So what that looks like is, again, I don't do anything to my first fraction. That still is just going to say 1 over x minus 1. But what I'm going to do is take out from that second fraction on the bottom a negative 1 from these terms. So it's going to make that x become positive and the plus 1 become minus 1. I did that so that I can get these two pieces to be the same. Now if I simplify that a little bit, so this minus, it's like 1 divided by negative 1. So it's going to cause that top to become a negative 1. If I add this here, 1 plus negative 1, well, those are opposite, so you get 0 over x minus 1. Well, 0 divided by anything is going to be 0. So in this case, it kind of all just went away. That won't always happen. Sometimes you'll be able to combine the terms that are on the top, but all I did from up here, like here to here, is I just transferred that negative up to the top, so that I could see that I had those opposite signs, so that when I added them, they canceled out and became a 0. So let's look at one more that's similar to this case. So again, this could be rewritten as negative n plus 4. So all I did there is switch those terms around. And so I'm going to pull out the negative 1, just like I did on that last problem. So I have 3n over n minus 4, we're leaving that alone, plus we have 6n, then I'm going to take out that negative 1 to make that negative n plus 4 become n minus 4. Then again, if you think about negative 6 divided by negative 1, I'm just going to basically transfer that negative sign up to the numerator. So it's going to say negative 6n is over that n minus 4. And really we're doing that so that our denominators match exactly now, and then we can just move the numerators and kind of calculate with those as necessary. So we have 3n plus negative 6n, which would be negative 3n, and then it's still over n minus 4. So this one did not get a 0 on the top, unlike the last one. And so I was able to simplify it by adding those like terms together, and then just leaving that fraction as is, because there's nothing that I could take out or reduce there. So I want you guys to try one of these on your own. So pause the video and then keep watching so you can see how it should have worked out. So again, what I would have started with is I would have actually switched the first one around because I like the letters to come first. So this would say negative x plus 11. Then I would factor out that negative 1. That way it says that x minus 11 that it does on the second fraction. Again, basically transfer that negative up to the top, so it says negative 3x over x minus 11 plus negative 5x over x minus 11. And then I'm going to work with my numerator. So negative 3x plus negative 5x would be negative 8x all over x minus 11. All right, if we take a look at these next examples, we're going to get into a little bit more complicated of a case. So for this one, we have bigger polynomials that are in the denominators this time. So what I would advise on a problem that looks like this one is to factor your denominators before you try to find your LCD. So remember with factoring, especially ones that look like these, you are going to be looking for numbers that do two things. So for the first polynomial here, x squared plus 11x plus 30, you want two numbers that would multiply to 30 and add to an 11. Well, that would be 5 and 6. So we can write it x plus 5, x plus 6. You're going to do the same thing for the second fraction. So I need two numbers that multiply to 20, add to 9, which would be 5 and 4. So x plus 5, x plus 4. So now if I look at my denominators here to state what my LCD should be, I need to make sure that all of my fractions have the most amount of times that I see some factors showing up. So I see right now that they have an x plus 5 in common. So I know I'm going to need that. And they already both have that, which is great. But if you notice that the first one has an x plus 6 and this one has an x plus 4. So those are a little bit different. So I'm going to need both fractions to have all three of these terms on the bottom. So I'm going to need an x plus 4, an x plus 5, and an x plus 6 for both fractions. Now, the first one already has the x plus 5 and the x plus 6, so it is only missing the x plus 4. So to get that first fraction to change, we are going to multiply by that x plus 4 quantity, and again, whatever we do on the bottom to get it to match, we have to do it on the top. Now, for the second fraction, you have the x plus 5 and the x plus 4 on the bottom, so that one is missing that x plus 6. So we have to multiply the top and the bottom by x plus 6. Now when you multiply in your numerators, because you're not going to actually multiply these terms in the denominator, you're going to keep them separated, but in the numerators you want to make sure that you distribute. Because you're taking a singular term, a monomial, times a binomial. So you got to multiply twice. So that first fraction is now going to say x squared plus 4x. All over our big denominator here, x plus 4 times x plus 5 times x plus 6. And then plus. Now we've got common denominators again over here, so I'm just repeating those three factors on the bottom. At the top, you're going to take negative 5 times x, which would be negative 5x, and negative 5 times 6, which would be negative 30. So now my denominators match. Let's work with our numerators. Try to combine some like terms here. So on the top, we have an x squared, because there's no other x squares over here for us to combine that with. We have 4x plus negative 5x. That would leave you with a negative 1x, or just negative x. And we don't have any numbers from the first fraction, so we just have this plus negative 30, so minus 30 here. And then still over that common denominator. All right, now remember how we were factoring the previous problems, especially the ones that we had started with. We're going to still want to factor that numerator. Okay, so just like we were factoring up here, those denominators, we're going to focus on this up here, and we're going to factor that. So two numbers that multiply to negative 30 and add to negative 1 are going to be x minus 6 and x plus 5. So I'm rewriting the top as those two factors, and then we still have that all over our common denominator. Okay, and the only reason why we would maybe want to do that is so that we could see, is there anything I could cross off from the top and from the bottom? So the x plus 5 quantities are the same, so we can cross those off. And so we're going to be left with x minus 6 on the top, all over x plus 4, x plus 6. So that's one of those examples I was alluding to earlier when I said you're going to want to make sure that you factor, if you can, so that if there's anything in common from the top to the bottom, you can get rid of it and cancel it. So I want you guys to go ahead and try to do this practice problem, and then come back and watch to see what the solution should have been. So this first fraction, to factor that, would be 2a minus 1, 2a minus 1. It's one of those special properties we talked about in chapter 8. So my least common denominator is to have 2a minus 1 twice, because it shows up 2 times in the first fraction. Now the second fraction has one of them, so we're just going to have to multiply that second fraction by another one to get both of them to have the 2. I don't need to do anything to my first fraction. We can leave that one alone. And I'm putting parentheses here so that I just remember to distribute on the top, which really what you could do on the top is kind of use that shortcut, that FOIL method that we've talked about in the past. So I didn't do anything to the first fraction, so I've got this 1 plus, if I multiply, or if you use like your distributive property here to multiply these two together, you're going to have a 2a squared minus a minus 2a plus 1 all over that 2a minus 1, 2a minus 1. Simplifying my numerator, starting with your biggest exponent, so again, think about descending order, so we have 2a squared, that takes care of that. We have negative a and negative 2a, so that'd be negative 3a together, and then 1 plus 1, which would be 2, all over that 2a minus 1, 2a minus 1. And there's your answer. So another area that this kind of problem can show up is when we're talking about distance in respect to how fast you're traveling and how far you've been traveling, or how long you've been traveling for. A while ago, way back at the start of the school year, we started talking about the D equals R times T equation. Distance equals your rate times time. So if you knew how fast you were traveling and you knew how long you had been traveling for, you should be able to figure out how far you've traveled, like how many miles you've driven. So we're going to talk about this equation a little bit today, but in some of these other examples that you might see these rational expressions showing up. So this first example says, for the first 5,000 meters, a hang glider travels at a rate of x meters per minute. Then due to a stronger wind, it travels 6,000 meters at a speed that is 3 times as fast. We want to write an expression to represent how much time the hang glider is flying for. So we can actually manipulate this equation up here to our advantage. So instead of having D equals RT, because they're asking us to figure out how much time the hang glider is flying for, we can rewrite this for T. So if I wanted to get R away from my T, I would divide by R. So my equation would be D over R equals my time. So for the first 5,000 meters, which would be your distance, it traveled at a rate of x meters per minute. So we don't know what the rate is, so 5,000 over x. And then the other equation says that it travels 6,000 meters. That is 3 times as fast, so 3 times that original speed, so 3x. So I'm trying to add these two things together here, but I need to have common denominators. Now if you look, the first one just has x and the second one has 3x. So I need them both to have 3x. The first one's just missing the 3, so I'm going to multiply the top by 3 and the bottom by 3. So that's going to be 15,000 for that first fraction, and then we still have plus 6,000 over our common denominator 3x, which this becomes 21,000 over 3x when you add the numerators. And we can simplify this just a little bit because 3 can go into 21 7 times. So this could actually break down to 7,000 over x. So this would be the equation that represents the two different speeds for those two different distances that we saw. Now there's a follow-up question here. It says, if the hang glider is flying at a rate of 600 meters per minute for the first 5,000, figure out the total amount of time. So they're telling us now what x is. They're saying that this 600 meters is your x. So what we can do is take this equation, 7,000 over x, and plug in that 600, and this would come out to be 11.7, and that would be in minutes, because it said per minute. It was meters per minute. So they've been flying for almost 12 minutes, but not quite. Now, additionally, they also then say if the hang glider flew for approximately 15 minutes, find the rate that the hang glider flew for the first 5,000 meters. So again, we can use this same equation that we found up above, that 7,000 over x. This time, we're trying to find the rate, so that's why I put x on the bottom. But we know that the time was 15, so equals 15. So to get x out of the denominator, we're going to multiply both sides by x. So we have 7,000 equals 15x. And then I would divide by 15. And so we're going to have x equals, if we round it, 466.7. And that would be meters per minute. So that would be their speed. All right, so let's take a look at another example here together, similar to what we just did there. It says that a train travels 5 miles from Lynbrook to Long Beach and then back. The train travels about 1.2 times as fast returning from Long Beach. If r is the train speed from Lynbrook to Long Beach, write and simplify an expression for the total time of the round trip. So again, I'm using kind of my manipulated expression where t, time, is equal to the distance divided by the rate. So we have two different parts of the trip. We have the trip there and the trip back. Now the trip there was 5 miles long, so that would be your distance. And we don't know how fast it went, so we can call that, you could use r if you want, or you can stick with your x if that's easier for you. And then we're adding that to the return trip. So the return trip is going to be the same amount of miles. So it's still going to be 5 miles between those two cities, because it's not as if the cities got any closer or farther apart in our trip there. But it went 1.2 times as fast. So we'd write 1.2x. So this is very similar to that one up above. I have to take this first fraction times 1.2 on the top and on the bottom in order to get that 1.2x. So 5 times 1.2 is going to be 6, and then we have 6 plus 5 all over this 1.2x now. And so this simplifies to 11 over 1.2x. And that would be our equation. Now if they asked us some follow-up questions like they did on the previous problem, then we could go ahead and use that equation to figure out like how long it took them to do this, or if you knew how long it was, what their speed was, like we could continue to go back and find those kinds of things. What I want you guys to do here is take a minute and try to do this last practice problem and then come back to see what it should have looked like. So for my equation here for this one, I would have written it as 15 over x plus 2 over 2x. What I need is a 2 to be attached to that first fraction's bottom. So now this says 30 plus 2 over 2x, which would be 32 over 2x. And we can simplify it a little bit because 2 can go into 32 16 times. So I would have had an equation of 16 over x. The follow-up question here is that if we know that they were traveling at a rate of 8 miles per hour for those first 15 minutes, let's figure out the total time. So that 8 is going to go in for your x. So you're going to take 16 divided by 8, which would be 2. So this person has been traveling for 2 hours.